Let us solve a question on utility function. The question is, consider the utility function of a consumer as u is equal to x square y on bundles x and y. The price of good x is twice the price of good y. If Gautam, which is a consumer, bought a combination of the two goods and in doing so achieved a utility of 1000, we have to find out the amount of good x did he buy. Options are being given. We need to find out the correct option. Okay, so we are being given the utility function is u is equal to x square y. Also we are being told that the price of good x is twice that of the price of good y. That is, price of good x is actually equal to twice the price of good y. Okay, and also the utility attained by the consumer is equal to 1000 here. Okay, we need to find out how much good x did he actually buy. Okay, so what we want to do, let us try to solve this. So let's first draw the graph here. So we have x good on the horizontal axis and y good on the vertical axis. Okay, so we need to find out the optimal bundle of the consumer. So optimal bundle of the consumer is actually equal to, so optimal bundle will be, to find out the optimal bundle, what we do, we equate the MRS with the price ratio, that is the price of good x upon price of good y. Okay, MRS, you know, it is simply the marginal utility of good x upon the marginal utility of good y, and we equate it with price of x upon price of good y. First thing is what we need to do, that very step. MUX is the derivative of the utility function partially with respect to good x. So du upon dx is actually the marginal utility of good x. So derivative of x square will be equal to twice x, and y will remain same because we are taking the partials with respect to x. Similarly, del u upon del y measures the marginal utility of good y, which is the derivative of this function with respect to y. The derivative of y is 1, so we are left with x square. Okay, now equate mux upon mvy with px upon py. That implies, so we got du upon dx is 2xy upon, and du upon dy is equal to x square, and we equate it with the budget ratio. So price of x upon price of y, we know the relation, that is price of x is equal to twice the price of y. So let's write twice py upon, here we have py. Okay, py gets cancelled. Okay, why did I draw this graph? To to explain that, let us say this is our indifference curve. We are being told that the utility that the consumer got is equal to 1000 units. Okay, and we need to find out the amount of good x that the consumer has bought. Okay, so I completely forget to draw the graph here. So here 1x gets cancelled, we are left with 2y upon x is equal to 2, which implies twice y is equal to 2x. So dividing both sides by 2, we get x, rather y is equal to x. Okay, so y is equal to x. So when y is equal to x, what we need to do, we need, and we also know that consumer is getting a utility of 1000 units. Okay, so in place of u we have x square y. So in place of u I write 10,000. Okay, so 10,000 should be equal to x square y, and the value of, and can I write it like this, sorry, it is 1000 is equal to x square times y is equal to x. What we got here when we solve this, let's plug y is equal to x. So in place of y I write x, which gives us x cube is equal to sorry, it is 1000. So x will be equal to 1 is 10 is 100,000 raised power 1 upon 2. If I transpose the exponent, it will become exponent but in reciprocal order. Okay, so we have 10 into 10 into 10 10 tens are 100, tens are 1000. So x will be equal to 10 cube. So it is here cube 1 upon 3. So this 3 and 3 gets cancelled. X will be equal to 10 units. So consumer will buy 10 units of good X given he achieved a utility of 1000 units, and also given that the price of good X was twice that of the price of good Y. Okay, I hope I make myself clear in this video. Thank you.